Yes, hello Aman, welcome on YourPedia platform and let's start your RAC snap for your final JKPSC interview.
Yes, sir.
So Aman, what is refrigeration?
So refrigeration is the process of maintaining a cool conditioned space below that of ambient conditions.
Mhm.
It may be it may be by two ways. We have two methods. By what one is the refrigerator and other is the heat pump. In a refrigerator, we maintain that condition space below that of ambient conditions, and whereas in heat pump we maintain that condition space above that of ambient conditions, depending upon the requirement of our.
So how we produce refrigeration, in our refrigerators or air conditioners?
So we use refrigerants. They take away the latent heat in the evaporator and throw that latent heat in the condenser. In this way, the transfer of energy takes place, and the lower temperature is maintained by the refrigerants by taking away the latent heat at lower temperature.
Okay. What is COP, Aman? What is the significance of COP?
Yes. So COP basically tells us about the running cost of in equipment we are using. If COP is more, then the running cost will be less.
How we can calculate COP, experimentally? For example, I have given you a refrigerator.
Yes, sir.
So how we can measure its COP?
Yes, sir. So we can first we have to measure the work input to the compressor. So we can take some millimeter where we can measure the voltage and the current for a specific period of time. So, and then when we have to measure the refrigeration effect. So I think we will take some bowl of water and put it in that condition space of refrigerator, and take the reading for that specific amount of time, and what is the energy transformation takes place, what is the conversion energy. But we know that temperature at which we are putting that bowl of water in the refrigerator, and what is the time after which the ice it becomes ice. So we can measure the refrigeration effect, and with the help of the millimeter or what we are using in the experiment, we can measure the work input, and in this way we can also measure the COP, which is the desired effect upon work input.
Aman, you heard about Electrolux refrigerator?
Yes, sir.
What is the working principle of Electrolux refrigerator?
Yes, sir. So Electrolux refrigerator is a type of BARS system, vapor absorption refrigeration system, which consists of three components. Basically, it is a noiseless operation because there is no usage of pump. So we have three components. One is the ammonia, and other one is water, and the third one is hydrogen. Ammonia is refrigerant, whereas the water is absorbent, and hydrogen, the function of hydrogen is to reduce the partial pressure of ammonia. So the due to reduction in partial pressure, the natural circulation will take place of ammonia, and in this way we can get the desired effect.
Can you tell me some of the advantages of VARS over VCRS?
So VARS, basically when we talk about VARS uses low grade energy, whereas VCRS we provide the work which is high grade energy. And VARS is used in those conditions where there is difficulty of electricity in very difficult terrain, where the work we don't have that amount of work, so we use waste heat in VARS, whereas VCRS we use high quality of work to convert to get the desired effect. The other thing is the COP of VARS is less than VCRS in somewhere between 0.3 to 0.5, and in case of VCRS we have 3 to 5 range of COP. And other thing is that VARS is a large capacity system, whereas VCRS we can use in domestic refrigeration, like in our homes we have AC system and refrigerators, we use that principle VCRS.
Aman, how we can write the enthalpy of most air? For example, you are having some most air.
Yes, sir.
Okay. So how you can write its enthalpy? Can you give me some expression for the
Yes,
enthalpy of most
yes, sir. Sir, as I'm
air?
able to recall, it is 1.005 into T. T is the divided temperature plus specific humidity. No, sorry, 1.88 into 2500 plus sir, 1.88. So sorry, I'm not able to recall at
So
this moment.
I'm not interested in the exact final expression. Just tell me the process. I mean, how we can get that expression. Just tell me the basic step to derive that relationship.
This enthalpy we get.
What is our aim? We want some expression for the enthalpy of most air. I mean,
Yes, sir, yes, yes. So enthalpy, sir, basically we can,
specific enthalpy of most air.
yes, sir, specific enthalpy of moisture. So we can, I say we can find it by mixing the enthalpy of dry air and the enthalpy of that water vapor.
Good, good. Then how we can write the enthalpy of dry air and enthalpy of water vapor? Goods.
Yes, sir. So we know
As
the
a first step. Fine.
yes, sir. So we have the mass, or we know we take some amount of mass of water vapor and the enthalpy of that, and other thing we take the mass of that dry water vapor and the enthalpy of this, and we divide it by total combined mass. Then we can calculate the enthalpy of moisture. Thing.
Sure. Aman, can you tell me something about the cascade refrigeration?
Yes. So cascade refrigeration is used where we have to we have to address our main area of concern, that is we have to obtain very low temperature conditions. So but in case of a single VCRS system we cannot obtain very low temperatures because there is a problem of decrease in the volumetric efficiency. We have to cater that thing also. So we use a series of VCRS system. So in this we also maintain the volumetric efficiency, and as well as we can also get our desired effect, that is minimum low temperature.
So Aman, tell me some of the desirable properties of a refrigerant.
Yes. So there are various type of desirable properties. Some of them we can talk about, like it should have higher critical temperature, and it should have, the refrigerant should have a high latent heat of vaporization. It should have the vapor specific heat should be high, whereas the refrigerant liquid specific heat is low. Also the thermal conductivity of refrigerant should be high, and its boiling and freezing point should be low. And other, in physical sense, with the it should be non-toxic or non-inflammable in nature. These are some of the properties.
Aman, the condenser which we use in our domestic air conditioner, maybe
Yes,
refrigerator. So that condenser is a air condenser, evaporative condenser, or water cooled condenser we use. What kind of condenser we use in our domestic air conditioner and refrigerators?
yes. So I think, as I am able to recall, sir, we use some kind of air condenser. So because there is small capacity, we have to adjust that condenser in small capacity. So we use the air condenser. But in recent times, we are using some kind of liquid also, which cools the which is used in the condenser, I think.
Sure. Aman, what is bypass factor?
Yes. So bypass factor, it tells us about the inefficiency of the coil. So it basically when the air is passed through the coil, the fraction of air that is not coming in contact with the coil tells us about the bypass factor. So bypass factor is the inefficiency of the coil, the air which does not come in contact with the coil. So bypass factor we can increase, but it is not desirable property of a that equipment, because it decreases the efficiency of that coil.
So how you can decrease that bypass factor?
Yes, sir. So one example, I think, sir, we can place multiple coils so that maximum amount of air should come in contact with the coils, and in this way we can reduce the bypass factor. More number of coils we are in arranged in the series, we have the formula, sir, in practical, x raised to power n, something like that. So in this way we can increase, I think.
Chalo. ठीक है, I think now I can provide you the
Yes, sir.
feedback. ठीक है, आपका understanding ठीक लग रहा है. You are looking confident. Okay. I asked you some of the question from basic BCRS, COP, measurement of COP. थोड़ा
Yes,
उसको और अच्छे से देखना कि how we can measure the COP practically.
Yes, sir.
Theoretical COP में, practical COP में क्या difference होता है? Experimental COP, theoretical और ideal, तीनों COP में क्या difference होता है? Okay. और कैसे measure करते हैं हम actual COP? Because actual COP is nothing but the experimental COP. For that we need to conduct some experiment. Okay.
Yes,
बाकी understanding ठीक है. I moved to some part of VRS, electrolux refrigerator cascade मैंने आपसे पूछा था. तो मेरे ख्याल से ठीक लाइन पे आप आंसर कर रहे थे अमन. ठीक है, your understanding is fine and your way of delivery is also looking fine. So as such there is no issue. Okay,
Yes.
थोड़ा और इसको और देखो, अपना इसको सुनना, how you can further improve your delivery style.
Yes, sir. Yes.
तो
Sir,
वो आप कर
confidence.
सकते हैं.
Yes, sir. Confidence level is okay.
कॉन्फिडेंस ठीक था. शुरू में थोड़ा सा आप मतलब मिक्स कर रहे थे वर्ड्स, बट
Yes, sir.
कॉन्फिडेंस ठीक था. ओवरऑल इट वाज फाइन अमन.
Yes, sir. Sir, I have knowledge, but there is some little bit of confidence level
नहीं,
decrease.
अगर मैंने पहले भी शायद आपने मेरे साथ कुछ स्नैप
Yes.
लगाए हैं,
Yes, two steps
तो आज
before.
आप कॉन्फिडेंट थे. मेरे ख्याल से पहले
Yes.
मैंने शायद आपको इस तरह का फीडबैक रहा भी होगा.
Yes, sir.
आज टुडे आई हैव नॉट ऑब्जर्व्ड एनी काइंड ऑफ नर्वसनेस. ठीक है.
Yes, sir.
डिलीवरी कैन बी फर्दर इंप्रूव. उसमें
Yes,
देखो,
yes, sir.
वो तो इवन सपोज देयर इज समवन एक्सपर्ट इन answering or delivering a particular thing, then also
Yes.
there is a scope. But
Yes.
as such, your overall, delivery is concerned, you answered most of the question confidently. तो
Yes.
nervous नहीं थे आप, confident थे, understanding भी अच्छा है. Some more, further you can improve your delivery style to make it more interesting. Okay, तो ये
Okay,
है.
sir.
बाकी ठीक है अमन. As
Yes.
compared to your earlier interactions, it was good.
Yes.
You answered all the questions actually.
Okay, sir.
Okay, man. Good luck and best of luck for your final interview.
Thank you, sir.